Okay.
Yes.
Okay. My talk is about the solving of a problem organized to is divided into two parts. The first one is the solar neutrino, the second one is about the detector, this Borexino is the detector in which I work. So let's remind you that at the core of the sun, temperature reaches about 15 million Kelvin. So at this temperature, proton can fuse in order to form alpha particle. If you made the balance of the reaction, you see that the 4 protons are lighter than the alpha particle is lighter than the 4 protons. So for each reaction, you get energy, and this energy is almost 27 MeV. The total power of the sun is, you see, 426 joules per second. So, what's about neutrino? My talk is about the neutrino. We start from 4 protons and we end with 1 alpha particle. So, you know that alpha particle is composed by 2 protons and 2 neutrons. So we have to convert 2 protons into 2 neutrons. This is possible by the inverse beta decay, in which a proton becomes a neutron, releasing a positron, and in order to conserve the electron number, an electron neutrino. I have to stress that it is an electron neutrino, no a tau neutrino or a mu neutrino. It has to be electron in order to conserve the flower electron number. So, neutrino, as you say, is a weakly interactive particle, so it can escape from the center of the sun where the reaction took place, and immediately go from the center in the outer space. For this reason, people conceive the neutrino as a way to test the nuclear fusion that takes at the core of the sun. So, this is the PP cycle, the reaction chain, in which you see we start from 2 protons and they fuse in order to form a deuteron, and being the deuteron composed by a neutron and a proton, you have, for the beta case as I said before, the emission of a positron and an electron neutrino. So once the deuteron is formed, it captures a proton and gives a helium nucleus and a gamma. So this is important. This gamma is, for example, has an energy of 5.5 MeV. It took, unlike the neutrino, it took a lot of time to go to space, about 100,000 years. We start from a single photon of 5.5 MeV, and because of the emission, the absorption in the matter of the sun, once it reaches the surface, you have millions of photons of some electron volt each. This is the visible light. So we have neutrino, we have energy, then helium can fuse with another helium in order to form directly alpha particle and 2 proton or other kind. In any case, you have different steps in which you gain energy in the form of gammas and neutrinos. Each neutrino has a name depending on which reaction is created. For example, this one is the PP neutrino. This one is the beryllium 7 neutrino, the boron A neutrino, the PAP neutrino, the F neutrino. You have 5 neutrinos in this reaction. I have to stress that for what concerns PAP and the beryllium 7 neutrino, you have monochromatic neutrino because at the end of the reaction you have 2 bodies. In the case of the other, you have 3 bodies, and the neutrino and positron have to share the energy, so you have a continuous spectrum, like in the case of beta decay. Actually, the spectrum of the neutrino is symmetric to the one of the positron. So this is the PP chain reaction, and represents almost all the energy released by our sun, 90%. But beside this cycle, there is also another cycle named the CNO, and in this cycle we have 3 neutrinos, from nitrogen 13, oxygen 15, and fluorine 17. In the sun, in a star like our, these represent almost 100%, but for every star it is more important, and for the heaviest star it is the predominant cycle. So if we put all together, we can see the spectrum. No chance. In any case, in blue there was a neutrino coming from CNO, and there was other, for example, VP chain is here and end until 400 kV. The beryllium 7 is 2 line at this energy with the tension ratio shown in the rectangle. The PAP was another line at 1.45. The boron 8 was this way. It goes until 15 MeV roughly.
Excuse me, perhaps you could use a big board.
So we have the flux versus energy. This is a logarithmic scale. For example, the PP neutrino I was speaking about has this feature until is a continuous pattern, as I said before, because the PP reaction has 3 bodies in the final state. For example, the boron 8 go until 15. Here is 0.4, for example, and this is about for each square centimeter per second we have 60 billion of neutrino, and for what concerns, for example, boron 8, only 6 million. You see, this area is much bigger than this one. This is 10,000 smaller than this one. This is logarithmic scale. So this means that, as I said, the neutrino was conceived in order to test the solar standard model. This is the spectra we expected in the case the reaction took place in the same way I showed before. So in the late 60s, Raymond Davis with John Baikal is the father of the solar standard model, start a huge experiment in an old mine in South Dakota. The fact that you have to go underground is due to the fact that you have to protect the detector against cosmic ray, because they give a big signal. So the detector that Davis employed was composed of a large tank in which there was more than 600 tons of perchloroethylene solution containing chlorine, and 35% of chlorine is chlorine-37. If we start with this nucleus, and if an electron neutrino impinging of chlorine can create argon-37, this is an beta inverse decay. So it's happened that argon is radioactive. So if you are able to count how many argon atoms are created, you can infer how many neutrino reach the detector. So the threshold of this reaction is 814 keV. This means that the neutrino has to have at least this energy in order to create argon-37. So it was expected that about 1 atom of argon-37 was created every 6 days. Imagine, we have 600 tons of solution, and only 1 atom every 6 days is converted into argon-37. So for this reason, we expect that Davis bubbling with helium through the tank in order to capture the argon-37 dated, and it is expected about 5 atoms per month. Okay. At this epoch, a new unit was created, the solar standard unit, neutrino unit. That means one capture